Hey everybody, Adam from Tested here in my cave. And for the past few weeks, we've been taking you on a deep dive through Husqvarna's products and how they get them from their factories all the way to your door. Today, we're going to talk about how they keep them running for you year in and year out. This is where Kelvin and his team come in. Kelvin has the awesome job of designing the torture tests for Husqvarna's forest and garden products. Kelvin walked me through Husqvarna's North American R&D facility to show me just how much stress their tools can take and how the data that they gather from these tests improves every generation of products for you. Good morning, Kelvin.
Good morning, how are you?
Very good. I'm very excited to be here. Tell me exactly where we are in the world.
So we're in Charlotte, North Carolina at Husqvarna at our Research and Development Center.
I'm so pleased about this. I cannot wait to see some of these tools in development and execution and to actually just play with them.
You're gonna have a lot of fun.
All right, let's get started.
All right.
Oh, okay, 3D printers.
Yeah, so this is our 3D print room. In this area, we do all of our prototyping with our starting designs.
And this is an FDM, this is a filament printer.
It is.
That's, both of these are putting that out.
Yeah, and they're capable of doing different sizes. So this machine here, we can actually print up to the size of a tractor hood. So the hood of a lawn tractor.
Really?
We can print that large in here.
And stuff like your guys are always mucking around. Wow.
Yeah. So anytime we have a new design, if we're looking at airflow or we're looking at moving something to another object, we can 3D print it first to try it.
So it allows you to do strength testing and part and fitment testing and airflow testing. It's almost everything you need out of the plastic you get out of the filament for testing.
Absolutely.
Amazing. I love this. This is, I think you guys sent me this exact battery pack.
Right, so that is for our 100-volt series, so the pace that you have. Mm-hmm. By doing the printing, it allows us to change airflow openings and do different things with it before we have tooling made and spend a bunch of money on tooling so we know if it's going to work.
So you guys might experiment with very, very different changes, small changes in the size of these holes.
Absolutely.
To increase or change the airflow.
Airflow, or even if it's just design the looks of it.
Right. Oh, so this will get passed around the conference table and people get a say in it.
Yeah.
And then this is, I'm assuming this is the prototype and the final.
Right, so again, we do all of our prototyping. We want to make sure that it's going to fit, that things are going to work the way that it's intended. So our model shop here has the capability of making any part that our design team dreams up. We'll 3D print parts, we can CNC parts.
Oh, you're making even the metal stuff, right? Of course you are.
Oh. Right. And then from there, we have our final production. And all this goes through our testing here. We'll start testing the fitments and then we'll end up testing the actual product.
Love it. I don't know about you, but I just love seeing something in the 3D printed casing. It's really neat.
And that's a case of one of our usable products that's been 3D printed.
That's fabulous.
That allows us to see what it's going to look like, go through some of our testing, and actually use it.
Sounds like it's making a lot of noise.
It is.
Oh, look at that. It's not even printing.
It's micro thin layers of plastic that gets laid down and then cooled and the next layer put on top of it.
So super, super high tolerance.
Absolutely.
Wow. All right, what's next?
Oh, let's go look at some of the testing.
All right. This is the part in the factory that is the most like my shop. This is the general purpose model shop where they can kind of do a little bit of everything. And there's just something I'm always jealous about when I'm in a room like this is how much room every tool gets to itself. Yeah, it's really nicely laid out. They've got space here and they use it. And you're just gonna use a tool better if it's got room around it and they know how to do that here. Kelvin, it looks like these are about to go for a ride, but they're not gonna move. What's going on here?
Well, that is the case. So this is our MTS room or our 4-post shaker.
Okay.
So we basically take our units and we will put them on these machines and shake them and move them around.
And this simulates them riding around throughout their normal operation.
Usage.
Okay.
So a customer riding across routes in their yard, as much as a customer trailering the unit.
So as vehicles, these things bounce around and your goal here is to bounce them to find all the things that could go wrong. Absolutely. So that they don't go wrong with the customer.
Yeah, we're looking at the way the decks are hung, the frame itself, the points where pressure goes into the frame that could cause a crack. If you get a hole that's too close to the edge of a piece of metal, that could crack. So that allows us to see that in our initial designs and find those flaws and get those out before we go into production.
And make sure the parts you're making aren't going to wear prematurely.
Absolutely.
Now, how do you replicate like hilly landscape with this?
So what we do is we take a unit and we use accelerometers on it.
Okay.
So we will pick multiple points on the unit to place an accelerometer.
In the field?
Yes. So we'll take the unit, put these accelerometers on it. We use a data acquisition device and we go out and use it.
Okay.
We'll give it to a landscaper, let them use it. We'll put it on a trailer and drive it for 100 miles and record all that data.
Oh, wow.
We bring that data back in, filter through it, basically condense it down, take out the stuff that's not needed,
right.
Very, very low impacts. And then we take that program, put it
feed
here,
it into here.
And we get the exact same information.
So, I mean, I'm just prognosticating here, but if someone called you from a golf course and said, our vehicles are failing at the same point every time in this golf course, you could send a vehicle out, track that material, take that accelerometer data, and come and test it here.
Yes.
Oh, that's really cool. And these things will be operating later. We can watch them go.
We're going to get these fired up and start doing some testing.
All right, let's do it. Kelvin, I feel like people watching may think that running this for thousands of hours like this might be overkill. But when I'm looking at this, I'm realizing that any bolt on this thing could potentially be not just a failure point, but could fall in a place that would make this thing very dangerous to be operating.
Absolutely. So you have a deck that's running with a belt.
Right.
And if a bolt falls and gets on that belt, it can get launched.
You've got it's spinning blades. Everything about this thing is so potentially dangerous. This is how you guys run all of those dumb failures off of the
Yes. And we go through these, even the nuts and bolts, and we'll put a tamper seal or a paint mark or something on it. So as we're doing our inspections, we know if it's moved.
Right.
So we're looking at every nut and bolt. We're looking at anything that can fail it.
So there must be sometimes certain arrangements of pieces that you now know, oh, if you try and do 5 pieces of this that are held by one bolt, it's too much vibration and you got to come up with another.
Absolutely.
You're always finding those little things.
Down to the grade of the bolt.
Really?
Yes. So
even down to its metallurgical properties.
Where we think one bolt may be strong enough for a certain part, this will show us it's not. So we have to increase the grade of the bolt that we're using to protect against that.
That's really cool.
Yeah.
Kelvin, tell me what's going on here with this bin of what looks like garnet in here.
That's close to what it is.
It's mostly okay. It looks.
So what we're doing here is blade testing. We test every facet of a mower, down to the blades. One of the biggest wear items is a blade.
Of course.
And you can look at this blade. This is a standard blade that you're going to go to any Lowe's or Home Depot and buy.
Yeah.
This one is one of our new blades that has a coating over it.
Okay.
Now, the purpose of that coating is to help reduce the wear. You're still going to get blade wear. It's not a miracle, but it is going to reduce that wear. We had to figure out a way to test that compared to a regular blade and
so
quantify that wear.
This is your bread and butter. This is a new process. You want to find out how much better this is than that.
Absolutely.
And that's where this comes in.
That's where this comes in. So you can see these are new blades. This blade here was this blade to start with that has been worn down through the media.
What?
So that's...
This is when it comes from the store, and this is after. What is it? So am I correct? These are simulating real world wear.
It is. It is.
How many years of use does this equate to?
That is depending on where you're at. So,
okay, sure.
So someone in the South is going to have a lot sandier yard than someone in the North.
Okay.
Someone in the South, that could be 1 year.
Oh, what? That's insane. And so, of course, you're going to coat it and try and figure out ways to extend that life.
Right. So when we look at the coated blade, the biggest difference that you're going to notice is the back of it, this wing.
Yeah.
This is actually what controls the way that your blade cuts because it's an airflow thing. So by putting this coating on it, we're able to keep an edge longer, but we're also able to keep this back flare longer, which allows it to maintain its cut quality.
And so now that I'm sort of grokking this, is this work just like a big mixer? The blade bolts in here.
Blade bolts on the bottom.
And this comes up to it.
We spin it at blade RPM, which causes lift. It sucks the media up and sandblasts the blade while it's turning.
Have you ever considered that to the tools you work with, you're officially like their version of hell?
Absolutely.
Like when a tool is growing up and it's thinking, what if I'm bad? You're going to go to the big sand pit where we're going to wear you down in a very short period of time.
That's what we get paid to do. We get paid to tear things up.
To abuse these things.
We want to find those failures so our customer gets the best product possible.
Well, so, I mean, I look at this and that result is interesting. It's
Both
also,
of these have been ran the exact same amount
Right.
of time in the exact same media. And you can see the wear difference between a non-coated and our coated blade.
No, and that's thrilling. I imagine that when you unbolt these, sometimes you're like, oh, like,
It's a lot of fun.
yeah, I would imagine. So what's the difference between the red stuff and the gray stuff here?
So this is unused media. So this is what we start with. After that blade has ran for roughly an hour, this is what it looks like. The color difference is the metal.
That's all the steel that's been 1 hour is enough
Yes.
to turn it from that to that.
So we get a year's worth of usage tested in an hour.
Now, do you then dump this or do you like run this through magnets,
No.
pull the steel out?
Once this has been used, this goes away and we start fresh again.
Amazing. That is really cool. Of course, I figured you must have, so what I really like about what I'm getting here is you guys have all of these mechanical ways of replicating real world wear, and you've been doing it so long, you know exactly how those relate to each other.
That's a big part of it, but we're always developing new tests. This test we've only been running for about 1.5 years.
Oh, wow.
We did one similar to this a long time ago.
Yeah.
But when we got into our new coatings, it's like, okay, now we need to figure out a new way to do it. And this testing took us 6 to 8 months to actually develop. Us playing back and forth with different medias, different speeds, different containers to even hold it in until we finally hammered down what we were after.
So every now and then you might be just like sitting there looking off into space and your partner will go, what are you thinking about? And you're just saying, I'm thinking about new ways to abuse saw blades. Okay, cool.
Or our engineers come to us, hey, I've got something new.
Yeah.
I need to test it. So we have to find a new way to test it.
Right.
That's what starts the conversations. We're going to do this. What do you think?
Oh, super cool. Oh, I'm sorry. Am I allowed to touch it?
You're fine.
Okay. I didn't want to mess up the... All right, Kelvin, when I first walked in here, I laughed because it's so absurd with all the tools running in here. This is just a tool testing room where these run until they drop.
Durability. We're seeing how long something can go.
Look, I understand how commerce works, and I know that square footage in any industrial space is hard fought over. So when I first walked in, I thought, this is a lot of space to devote to running tools. And then I realized that they have ends that are dangerous. They run hot, they run noxious gases. Like everything about this room is about corralling the safety so that they can run.
Absolutely.
Incredible. Okay, so we got petrol on this side, and this is all battery.
Yes.
This is kind of new for you guys.
It
battery
is.
test.
So we've stepped into the battery world in the last couple of years. With that, we've had to change some of our testing methods, the way that we do it. But the tests we do are still the same. We're still after how long is that unit going to last? What's going to break on it? What's going to wear out first?
So it's just vibrating it for however many hundreds of hours until the first thing fails. And
Right, but we're looking at different things too. With our battery units, we're looking for wires that chafe. We're looking for capacitors that go bad, things of that nature.
Right.
We're on our petrol units, we're looking at pistons and cylinders and carbon buildup in the exhaust ports and mufflers and things of that nature.
And so this is institutional knowledge that you have been building for decades.
Right.
And this for only a few years. I'm curious if there's non-obvious things that you've noticed about the battery versus the petrol, besides the obvious ones.
Again, the biggest overcoming thing for us has been locating those wire chafes and the vibrations that you get from that unit running.
Right.
And the differences, because when you look at a unit like this that has a brush on the bottom of it, the harmonics and the vibrations that it feels is different than a tiller type head versus a trimmer head. So we see a lot of differences in what happens to that unit over time. based off of the different attachments that our customers are able to put on the unit and the way that they use it.
I noticed too that most of the battery operated machines have the battery in them, which I would assume is mission critical because the battery also gets abused.
Well, there's two ways. So these that we have on test have a battery in place, but that's not what's powering it. We're powering it off of a power supply that gives us the exact voltage that our battery does. So we're not having to change the batteries every 30 minutes.
But you were also able to witness wear on that battery.
Right.
Fascinating.
We also do this same testing with batteries.
Sure.
So we will run a gamut of testing with the battery, recharging the battery, going through charge cycles just like a customer would. Right. But when I'm running hundreds of hours, that's not feasible. So we had to come up with a new way of doing it.
Do you still laugh when you walk into this room? It's absurd. The noise level
I wouldn't say
insane.
I laugh, I smile. I love it. we love what we do. We love testing these products and seeing what happens so we can make it better.
It is like a really twisted Santa's workshop in here.
It is. It is.
All right, Kelvin, I'm slowly dawning on me that every condition your products get used under is the worst possible conditions.
We try to prepare for that anyway.
I was looking at a snowblower, and that was what occurred to me. This is a cold test chamber for running your equipment below zero.
Yeah. We actually have the capability of going to about -20, -25 degrees with this particular chamber.
All right. What current temperature is it at?
So right now we're at about -13.
Okay.
And I'm going to take you inside. We're going to do some impact testing. We have to make sure that our plastics don't break in different conditions. And you saw some of our certification testing.
Yeah.
This is a certification test that all of our competitors and ourselves have to go through, where we're impacting plastic at that temperature to make sure it doesn't crack or break.
Because its properties could change. Like it's one thing at 70 degrees Fahrenheit, but at 13 below zero, it may break like an ice cube.
And then we take it out of here and we put it in a second chamber that we heated up to 110 degrees and impact it again. So we're going through those temperature cycles and those changes because the molecular structure of that material will change through those temperature ranges.
Yeah. These are just, there's so much energy going on. There's so much energy in the tool itself, but I find it fascinating that so much of your job is just equating the abuse it's going to get in the real world here under controlled conditions.
A lot of thought goes into it, a lot of thought.
All right, so this is actively, no one stores their lunch in here or anything like that?
No, we have frozen popsicles in here a time or two.
Well, can we?
Let's go do some testing.
Okay. Oh, all right, here we go.
All right.
Oh, it's, okay, I know it doesn't sound surprising, but it's freezing in here. Oh, it's absolutely freezing. I mean, of course it is.
Now, with this particular test, what we're doing is we have a 5-pound weight that's going to smack the bottom of this trimmer shield.
May I touch?
And we've got, absolutely. We've got this set up to where there's a stop. That way we can repeat it.
So it's always coming, it's always delivering the same amount of force every time.
That way it's repetitive.
Oh, and you put this above this and pull it? Or
no, we just
bring it up here and let it swing?
And hold it against it and let it go.
Oh, wow.
What it's going to do is it's going to cause this trimmer to swing out because you're going to get that momentum from it. I'll catch it, but we go through this with 25 impacts. 25
impacts for each piece that you might be testing.
Here, and then we do it again in a hot chamber.
So it's a weird day. You bring a very heavy coat to work.
You can be in here most of the day. You want to impact it?
I totally do.
All right, pull it back against the stop and let's let it go.
So this is just a billet of 3.5-inch steel.
Now it is a specific weight, and that actually has a gauge number. This one's our reference only. Because we're doing this here, we're not using my specific gauge. Don't want to damage it.
Understood. Okay, here, are you ready?
Yep, let's do it.
3, 2, 1. And you will do that multiple
25 times.
2 dozen times. Jeez.
And then we'll take it apart. We inspect it, make sure that there's no cracks or breaks in it.
Right.
We'll go to the next temperature and do it again.
That's spectacular. Let's wrap this sequence so I can get back out of here. It's so cold. That's hilarious. Oh my God, it's bone chilling. That's spectacular. This is my souvenir from Husqvarna. Thank you guys so much for watching this series. It's been such a blast. I want to thank everyone at Husqvarna who let me into your R&D and manufacturing facilities. It was such an adventure. It was fabulous getting to meet the teams who design, build, and manufacture these tools, as well as meeting the engineers who are pushing these technologies further, specifically by abusing their machines. It's so much fun. And I mostly love knowing that somewhere out there is a Husqvarna zero-turn mower that I played a small role in assembling. Thank you guys so much. See you next time.